we've got the periodic table, and we've been going through the different families on the periodic table. And I pulled this up. This was something we saw earlier. This was the just the overall how the periodic table is broken down into different families. And we knew that there was this stair-step line, right? The stair-step line that's over here on the right side. And everything to the left of that stair-step line are the metals. And for the most part, everything to the right side of that stair-step line are the non-metals, right? Yes, there are a few metalloids here in the middle. Those are the ones that are sort of metal, sort of non-metals in between. And yes, there is a non-metal way over here. Hydrogen is a non-metal, even though he's way over here on the left side. Kind of strange. But for the most part, it's pretty easy to tell where the metals and the non-metals are. So we're going to start with the alkali metals, which are the elements there in group 1. So if you go to the very left-hand side of the periodic table, you should have a periodic table out. You should be looking at it. If you look at those alkali metals that are in group 1, they're all metals. So they do all the things that metals do, right? So they conduct electricity really well. They conduct heat really well. They don't come in a lot of colors. They're generally shiny. They're malleable. They're ductile. They're generally solids. Okay, all the things that metals do, but these specific metals, these alkali metals in group 1, are really, really reactive, like explosively, violently reactive with other things. They generally have low melting and boiling points, and they're very light and soft. We generally think of metals as being really strong. You can make things out of it that are really strong. These are not those kind of metals. They look like the metals you're used to, but they don't act like them. And like we just mentioned, their atoms have one valence electron. So all of the elements in group 1, besides hydrogen, remember hydrogen is actually a non-metal. Even though he's way over there on the left side of the periodic table, hydrogen's kind of weird. So we kind of leave him off this list. But all of the other elements in group 1 are part of the alkali metals. So that's lithium and sodium and potassium and rubidium and cesium and francium. And some of those you probably have heard lots about, right? You've heard of sodium in your life. You've heard of potassium in your life. You've probably even heard of lithium when we talk about batteries. Rubidium, cesium, and francium you probably have not heard much about outside of this class. And that's all right because they're not that common. But of course, these three we talk about a lot, and they are all metals. In fact, they all look pretty much the same. They're a shiny gray metal, which are very reactive and very explosive. The alkali metals, right, they're a little bit different than what we're normally thinking of with metals. If we just move one group over to group 2, we get to the alkaline earth metals. They're also reactive, but they're less reactive than the alkali metals were. They're still light and soft, but not quite as light and soft. They're a little stronger, a little denser than the alkali metals, and these atoms have 2 valence electrons. So what are we talking about here? We're talking about the elements in group 2, like beryllium, magnesium, calcium, strontium, barium, radium. And again, some of these I know you've heard of before. I know you've heard of magnesium and calcium before. Right? And all of these are going to be really similar. You notice if you look at pictures of them, they all look pretty much the same. They're all a shiny gray metal. And some of these metals are very much responsible for the different colors you see, for instance, in fireworks. And then we get to the transition metals. Remember, the transition metals are that big area in the middle of the periodic table. Groups 3 through 16 is generally what we'll call them, right? They're even less reactive than the alkali and alkaline earth metals, and they're generally stronger. And how many valence electrons they have varies quite a bit, right? So the transition metals that we're talking about are all these guys in the middle We'll throw the intertransition metals in with them, and even a few of these over here generally get thrown in also with them. So we're talking about copper, lead, tin, nickels, well, steel's an alloy. I don't know why they have that in the picture. And then zinc, right? And then there's a lot of other ones, right? Gold, silver, aluminum, lead, right? There's a lot of them. And for the most part, they're gray, shiny metals. Yes, there are a few exceptions, copper, gold, but mostly they're not, right? So let's start way back over by group 13. Okay, so group 13 has a few different kinds of elements in it. Group 13 starts up at the top with boron. Right? And boron is actually a metalloid. And then below that, we have some of those other metals that we've sort of lumped in with the transition metals. Okay, but they are in group 13, and that would include aluminum. Right? Aluminum is the most abundant metal in the Earth's crust. Right? It's one of many reasons why we make a lot of things out of aluminum. Right? There's a lot of it out there. It's pretty cheap to find because there's a lot of it there. And it works pretty well for a lot of applications that we want to do it with. And then, of course, there's other elements here that we don't hear a lot about. Gallium, indium, thallium, that we don't hear a lot about. They don't have as many uses. And if you go one over from there into group 14, right? Group 14 is the carbon family. So it starts off with carbon. So carbon is a nonmetal. Right? Completely a nonmetal. And then we have a couple of metalloids. So like silicon and germanium are metalloids. And then we get to some metals at the bottom of that. So this is right in that middle of that stair step. And that's why we have a few different kinds of elements in this group. Right? Since we're in group 14, remember, 4 valence electrons. We learned that pattern the other day. And then silicon, which is in this group, this is part of the metalloids, right? Silicon is the second most abundant element in the Earth's crust. So aluminum and silicon happen to be very abundant. Right? There's a lot of it out there. And then we get to group 15, and group 15 is known as the nitrogen family simply because it starts with nitrogen, which is also very abundant, and it's a nonmetal. Phosphorus underneath that is also a nonmetal. We get a couple of metalloids, and there's still a metal here, right? In bismuth. Nitrogen is big because nitrogen is used in living things a lot, right? So there is a nitrogen cycle. If you have taken biology, you probably learned at least a little bit about the nitrogen cycle. There's also a phosphorus cycle. You may have not have learned about this before, but on the Earth, there is a constant recycling of the phosphorus also. And there's a lot of phosphorus out there. And remember, since we're talking about group 15, they have 5 valence electrons. Then we get to group 16, which begins with oxygen. So oxygen and sulfur and selenium are the nonmetals in this group. And then we have a couple of metalloids that we don't hear about very often. And they would have 6 valence electrons because they're in group 16. By the way, you can see in the picture here, you can see a picture of sulfur. So that would be bright yellow. It's easy always to tell sulfur from a lot of other things. And then we get to the halogens. Group 17 are known as the halogens. This is a really important group. They are very reactive. Just like the alkali metals were the really reactive metals, the halogens are the really reactive nonmetals. So they include things like fluorine, and chlorine, and bromine, and iodine. And there's astatine down there at the bottom. But all these halogens here are really important because they end up reacting with a lot of those really reactive metals and producing things that we use all the time. Like chlorine by itself is just this green noxious gas, right? It It would burn if you tried to breathe it in. You wouldn't be able to do it. But if you take chlorine and sodium, which was that really reactive metal, and when I put it in water, it almost exploded. If you put sodium and chlorine together, you get sodium chloride, which is just salt. And you need that to live. So you understand that even though these elements by themselves may be very dangerous and not very healthy for us, together they can make substances that are really important for us. And then finally we get to group 18, which are the noble gases. Group 18 has 8 valence electrons, which happens to be the most valence electrons that any atom could have. And the thing about that is, since it has completely all of the valence electrons that it could possibly have, it's really happy and stable. So noble gases don't feel a need to have to react with anything. And that's why they're called the noble gases. Right? So they're all nonmetals. They're all, of course, gases. That's why we call them noble gases. They're all odorless, and they are unreactive. Right? I guarantee you right now, you are breathing in some of these gases as we speak. There is a tiny bit of helium in the air at all times. There's a little bit of neon. There is actually a decent amount of argon in the air at all times. But you would never know that because it's unreactive. Right? It's not something that you're going to necessarily be able to tell that's even there.